Okay, so first one. Okay, so look how you have to use your knowledge and how good you have to use your knowledge. A train accelerates from rest to a speed. So u is equal to 0, v is equal to 40, ms minus 1. Then time is equal to 250, right? Seconds. The train has a total mass, m total, is equal to 7.5 times 10 to the power 5 kg, right? So I'm doing it a little fast so that this is how you have to do. The train motion is opposed by the friction force. Friction force, that means Fr is 1.8 times 10 to the power 4 Newton. Understand the story. Okay, so the train is driving up a 1 degree slope. Okay, what is the net force on the train during? What is the net force? So the first one. Okay, so the net force, we understand F net is equal to ma. That is the first thing. So here we know m, but we don't know a. So that's why all the other informations are given to you. So you can use v squared is equal to u squared plus 2as. You can't use that. Why? Because you don't know s, right? So what you can use is v is equal to u plus at. Yes, you know v, you know u, you know t, you don't know a. So from there you can find a. So a is equal to v minus u divided by t once you subject that. So a is equal to, now 40 minus 0 divided by t is 250, and the answer would be 4 divided by 25, ms minus 2. So it should be like that fast, right? And then m would be 7.5 times 10 to the power 5 here multiplied with 4 divided by 25, and the force should be given in terms of Newton. So in other words, you can have, this is kg, ms minus 2, that would be equal to 1 Newton. That's fine. What force is applied by the engine during this time? What force is given by this time, right? So you understand B part, F net is equal to F driving force minus F friction force. How come? If you have a mass here and this is F driving and this is Fr, so the net force is this. So this is the definition. So now you need to find F driving, that would be F net plus Fr. So F net you found already, 7.5 times 10 to the power 5 times 4 divided by 25, and minus, so not minus, plus the friction force is already given to you, 1.8 times 10 to the power 4, and that would be the F driving force. Yeah, okay, so that is fine. So question number 2. In question number 2, a train consists of an engine of mass 20 ton, okay, towing blah 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 10 tons, and then direction of the motion is given, then wagon, everything is given in the question. The train accelerates from rest with a constant acceleration. Okay, so you have that, you have this. So here you should have a force here, right, driving force. Then you should have tension here. See, even without doing anything, you know the details. Now, do they have, I don't know whether the friction is mentioned here, but still acceleration is given to you, 0.1 ms minus 2. That's fine. So this is m1, m2, this picture is fine. So now, calculate the speed of the train after it moves 20 meters. So now the question is saying the train accelerates from rest. So that means u is equal to 0. The whole system is moving from rest. And then calculate the speed. You need to find the speed v when s, or the distance, is 20 meters. Acceleration is already given to you, 0.1. So it's easy peasy. What you have to do is, we will use v squared is equal to u squared plus 2as in horizontal direction. So v squared, u squared is equal to 0 plus 2 times a 0.1 times s would be given 20 meters. So you get 2 times 2 4, answer is 2 ms minus 1. Just few seconds. Then the wagon has friction resistance. The wagon has a frictional resistance 2000. Okay, so the now wagon is this, right? So frictional resistance is 2000 Newton. Calculate the tension in the coupling between the engine and the wagon. So you need to find T, right? So in the B part, so now when you need to find that, we have to throw our experience. So this is our friction force, this is our tension, right? Acceleration is already there, right? Acceleration is already there. So then we can use F is equal to ma in this direction. So if you do that, T minus Fr is equal to m times s. So tension is equal to Fr plus ma. So first of all, you have to formulate the math like that and then do the subbing in. So it's going to be 2000 here plus m would be, I think 10,000, right? 10,000. 10,000. A would be 0.1, I guess. So it's going to be 3000 Newton is the answer. All good. So now question number C now. Question number C. In another situation, the engine of mass 20 and moving with 3 ms minus 1 collides with a stationary wagon which is mass 10 tons and couples with it and goes like that. Okay. So that means what you have to do, calculate the speed of the train. Okay. The engine of mass, this one, collides with a stationary wagon. The train means the engine with the wagon together, right? Engine, wagon together is a train, right? So you have to understand the language here. So this is M1, which is V1 here. So this is M2, which is V2. Sorry, my language is little wrong here. Initial stuff you have to write U1 and U2. See, I catch it like that. It's barehanded, right? So you need to find U here. No, actually U is given to you. It's given to you 3 ms minus 1. So they couple now like that, M1, M2. So you need to find this V1. So now V1 makes sense because V is denoted for the final velocity, right? So what you can do now, you can use momentum conservation. Momentum conservation. So you have to write, so this is called linear momentum conservation, okay? Linear momentum conservation. So linear momentum conservation, in this you can write M1 U1 plus M2 U2 is equal to M1 plus M2 times V1. So M1 is 20 here. So 20 times 10 to the power 3 times U is 3 plus 0 is equal to 30 times 10 to the power 3 times V1. Grade 10 math, we are not going to dance around. So it's going to be V1. So now you can see 10 to the power 3, 10 to the power 3 gone. So it's going to be 60, 60 divided by 30. It's going to be 2 ms minus 1. Straightforward. Okay. Next one. Determine whether the collision shown in elastic or inelastic collision. Right. So elastic collision means what? Elastic collision means what? Elastic means no energy loss, right? So that means delta E is equal to 0, right? So now what we can do, now energy before would be half into M1 U1 square plus half into M2 U2 square, right? Now why this notation is so important, M1 U1 M2 U2 V1 V2 and all those things, because U is the initial, V is the final, U1 is for the first object, U2 is for the second object. So then you will see that when you have a first object, now when you are in the second part, you know the language, right? U1 is for this one, U2 is for this one, right? So you can write it that, write the statement like that. Okay, so that's how the math is made. Okay, logically. So half into m1. What is m1? 20 term, right? 20 times 10 to the power 3. Now you can see how I am writing 20. I'm not writing 20,000 here, right? So you have to be smart enough to do that, right? So rhythmic work should help you for that. 9. So plus 0 here. So this is going to be now 10 to the power 4 joules, right? See, easy. Now E final. E final should be half into m1 plus m2, right? So V1 square. So now half times 30 times 10 to the power 2, 10 to the power 3 times V1 would be 2, right? It's going to be 4. Now this is going to be what? It's going to be 2 here, 60, 6 times 10 to the power 4 joules. Is that right?
I think A before.
Yeah, so E1 is wrong, yeah? This is wrong because I didn't see 9 there. So it's going to be 9 times 10 to the power 4, yeah? Yeah. So now you can see E before minus E final is equal to 3 times 10 to the power 4 joule. So that means delta E is not is equal to 0. So this should be inelastic then. That should be inelastic. Okay. In another situation, the engine moving to the right 2 ms minus 1 collides with but does not couple with the stationary wagon of 10 tons. That's why find the collision. After the collision, the wagon moves off to the right at this. Calculate the velocity of the engine after the collision. Okay. So this part is like this. So you have m1 here, you have m2 here, so you have u1 which is 3 ms minus 1, so you have u2 here which is 0. Then what will happen? m1, we don't know this one, right? So this velocity we don't know, but m2, that v2 would be 2 ms minus 1. So you need to find v1. So again, linear momentum conservation. I'm not going to write it, but you have to write linear momentum conservation. Why? The reason is, so when you write a answer, you have to understand, you have to write the law first, right? Law or theory or any logic, that is the first thing you have to write. So using linear momentum conservation. Second one, algebra, means simplification. Third one, you are going to do conclusion. So understand this in math and physics. Okay, so this is how they give you marks. So linear momentum conservation I'm going to use here. So m1 u1 plus m2 u2 should be equal to m1 v1 plus m2 v2. So m1 now should be what is m1? What is m1 here? 20,000, right? u1 is 3 plus 0 is equal to, this is 20 times 10 to the power 3 times v1 plus 10 times 10 to the power 3 plus 2 times 2. So now I can see 10 to the power 3, 10 to the power 3, 10 to the power 3 gone. So I get 60 from here, 20 from here, 20 from here. So it's going to be 40. So v1 is equal to 40 divided by 20 is going to be 2 ms minus 1. Right? Yeah, it's a different value now. So it's going to be 2 here. So that should be 2 here then. So it should be 40 then, right? 40, then it's going to be 190. Yeah, good. Okay, next question. In the next question, you have a situation like this. A situation like that. So I would say M1 here, M2 here. So tension forces are like that, right? And M2G. So throw your experience like that. That's fine. And the system is initially at rest. Okay, that's fine. Ignore the mass and the friction. So the friction is no longer there. So mu should be 0 there. So then calculate the acceleration of M1. So acceleration of M1 would be the acceleration of the system, right? Okay, Rohan, wake up. And then F is equal to ma for the system, right? So the only F net force would be M2G, which is equal to M1 plus M2 A, right? So A would be M2G divided by M1 plus M2. So it's going to be M2 is what? 1. So it's going to be 1G divided by 5. So that's acceleration. So if G is 10, you can find the answer. Okay. Then, so calculate the acceleration of M1. That's fine. Calculate the magnitude of the tension in the string and the mass of the acceleration. Okay, fine. So the breathe part, what you have is, if you think about M2 here, so it's going to be M2G and this one T here, right? So you have acceleration here that you found. So what you are going to do is you are going to use F is equal to ma for that M2 object in the down direction, where you have M2G minus T is equal to M2A. So you can find T here. That's going to be M2G minus M2A. So M2 is what? M2 is 1. G minus, again 1 times G would be, A would be 1G divided by 5. So if you take the common denominator, it's going to be 5. 5 minus 1 is going to be 4. 4G divided by 5, and that would be the tension in newtons.